Hello and welcome. This is Verzi. In this presentation, we are focusing on symmetric encryption algorithms in the module of information security. Totally in this presentation, we are gonna cover cryptography in general and symmetric encryption algorithms more specifically. First, a quick dive into cryptography. Cryptography is a science of securing information or encoding information during the transmission of the message between users. We have five terminologies of cryptography here. First, we have plain text and ciphertext, encryption, decryption, and finally keys. This is the encryption and decryption process. First, we have plain text. Plain text is the message that is understandable by everyone. We have plain text. To make it unreadable, we can encrypt it using a key. Then the output is a ciphertext. And then from the ciphertext, if you want to get back the result, the plain text, the understandable text, we can decrypt it via a decryption algorithm to the plain text as a result. Key is a factor between them, and key is a string of bit or alphanumeric bit. And here key is a string of alphabet or alphanumeric or any symbol between them that are used to the encryption and decryption algorithms. Now here we have cryptography main goals, which we concluded into four sectors, I'm sorry. First, we have authentication. Authentication confirms identity for resource accesses, and the confidentiality ensures that the content of a message is protected through the encryption and allowing only the intended recipient with the proper key to decipher and understand it. Data integrity ensures only authorized alteration of a message. And finally, non-repudiation prevents denial of message transmission by ensuring that neither the sender nor the receiver of the message should be allowed to deny the transmission of the message. And we have cryptography algorithms classification tree. Cryptography were divided into three different groups of algorithms. First, we have asymmetric encryption and symmetric encryption and hash function, which they are different in the encryption and decryption algorithms and sharing the key, while hash function doesn't have a key. It just encrypts the message into non-understandable and non-reversible message. For the symmetric encryption, we have a same key or a private key for the encryption and the decryption process. But for asymmetric encryption, we have a public key, which may differ between the private and the public key. We are going to talk about symmetric encryption in detail in the next slides. This is a cryptography algorithm's extensive classification tree. We have cryptography in the modern and the classical ciphers, which it is demonstrated extensively. Now heading to second section of the presentation, different algorithms, critical parameters. We have some critical parameters on different algorithms. First, architecture. Architecture refers to the structure and design of cryptographic algorithms, outlining how they process and secure information. For security, security focuses on the robustness of cryptographic algorithms in protecting data and assessing factors like encryption strength and resistance of attacks. For scalability, scalability examines the ability of cryptographic algorithms to handle increased computational demands and evolving security requirements as systems grow. And finally, limitations. Limitations involves considerations such as vulnerability to specific attacks, computational intensity and adaptability challenges in certain applications. Now we are heading to this third section of our presentation, which is symmetric encryption. In symmetric encryption, the process of encryption and decryption to a single key, and it will be divided into two groups. First, block cipher and stream cipher. For the block cipher, it will encrypt or decrypt the message as a block of bits or bytes, but for the stream, it will encrypt bit by bit, so it will be a little bit slower than block cipher, which each has its own children of encryption algorithm. In continuing to symmetric encryption, in this figure shows the crypto system problem statement illustration of symmetric key. First, if we send a message from A to B, we need to have a key, and sending the key via a secure channel. If we send it via unsecure channel, so bad guy may listen to the message and understand it. But when we send the message in a secure channel, the bad guy may not understand the text because it is encrypted. And now heading to the fourth section of our presentation, which is common symmetric encryption algorithm. There are many different encryption algorithms in cryptography, but we are going to cover four of them, which is Caesar cipher, Data Encryption Standard, DES, and the Advanced Encryption Standard, AES, and also Vigenère cipher. Now we are heading to Caesar cipher. Caesar cipher is the most ancient cryptography algorithm that are founded by an Egyptian people, an Egyptian person, and the background of Caesar cipher is shifting the plain text letter bit by bit or digit by digit. So every letter will be shifted depending on the key. And for DES is one of the basic symmetric key block cipher algorithms, which takes plain texts as blocks. And the DES algorithm performs two permutations, initial permutation and final permutation, and 16 processing steps, each of which is called a round, and for each round a different key is used. This is a figure of encryption process in DES cipher algorithm. DES is based on two cryptographic operations, substitution and transposition. In each round of DES, some substitution and transpositions are performed. Before starting the first round, an initial permutation is applied to the plain text. The resultant permuted block is divided into two equal halves, and each of them is going through 16 rounds of encryption processes as well. So the final permutation is applied to the combined block to get the ciphertext. This is a quick overview of DES, and now we are heading to AES. AES is also a symmetric key and block cipher, and it is invented to replace the DES, and it is much better than DES. This figure is also an encryption process of Advanced Encryption Standard cipher algorithm or cryptographic algorithm. AES is a block cipher algorithm that came as a replacement for DES. So it encrypts and decrypts 128-bit or more blocks of data based on the choice of the key. So the higher the key size you have, the more secure the message will be. AES can take 10, 12, or 14 rounds for encryption. Each round consists of 4 operations: substitute bytes, shift keys, and mix column, finally add round key. However, mix column operation is not performed in the last round, so separate round keys generated from the given cipher key are used in each round of encryption. Data to be encrypted is divided into blocks. Each block is represented as an array of data, which is known as a state array. And finally, AES is not vulnerable as compared to DES, and AES is also known to provide a good level of security as compared to DES. And now we are heading to the general cipher. The general cipher is a polyalphabetic substitution cipher, and it is also a classical one, not a modern. So according to the instruction, we cannot mark it as a symmetric encryption algorithm. So depending on the technique, because in this general cipher, both sender and the receiver of the message use the same key to either encrypt or decrypt the message. So we can call it symmetric, depending on the technique, on the encryption and decryption technique. This is a mathematical representation or equation of the general cipher, both encryption and decryption. And this is the table of the general tableau, or a square table. And this figure is a table of the general cipher, which is called the general tableau sometimes. Depending on this row and columns, we can encrypt and decrypt a message. For example, in this plain text, and not gonna forgetting it, the cipher is encrypting the message digit by digit, as demonstrated on this table. First, we have T in the plain text, and we have a key of networking. It should be a string. So the ciphertext will be like that. So let's do the encryption process. We have T, letter T in the plain text, and this is the plain text. Let's find T. We have T here, and our key first letter is N, so we can match the T to the row N in the table. We will get G in this indices of T and N according to the key and the plain text letter. For the second one, E, we can find E here, and going to the second letter of the key, which is E. So we find E by E. E by E will be like that. Will get us I, right? So it will continue till all of the letter in the plain text. For the key, we have to repeat the key until reaching the length of the plain text, if it is less than it. And for the generated cipher, I have implemented a simple Java program which will encrypt and decrypt a message. Let's execute the code and see what will be the output of these different plain texts. And we have this code I have implemented to do encryption and decryption for the generated cipher. We have these keys, and let's run the program. For the initial state, I have set it plain text to Technical College of Informatics, and the ciphertext, the key of networking. Let's see how the ciphertext is. The plain text is Technical College of Informatics. This is the length of the string. It is not important, but I have showed it to be more clear. And this is our key, networking. We have to extend this key or repeat this key until it reaches 28 or higher. So depending on the key, it will match the plain text and the key into the encrypted text, into the ciphertext on the table, on the tableau table or the general table. We have this encrypted text. Then we decrypt this. We will get the same plain text as we have before. So let's do some changes. For example, we are going to change the plain text. For example, change to this is a test. This is a test on with the key of networking will be like this as a decrypted text or the ciphertext. And now we can change the key to something else. For example, we input true as a key. The key changes from networking to true. Okay. And we can now print the text. We have this plain text. This is for test. Okay. With the key of true, it will be repeated till the plain text length 11. We get this. We can print it to see it more. So this is the Java program. If you want to have it, you can scan this QR code. It will bring you to a GitHub file of the code. This is all the presentation. Let me know if you have any question in the comment section, and have a good day.